Hello folks, welcome to the GDTOLOGY Channel. Today's topic is what are datums? Now, there's a lot of misconceptions of what datums really are. Many people will, let's say, take this part and say, well, this weird surface right here is datum A, this hole is datum B, and this surface right here is a datum C or something. Now, I want to clear things up. There's datum features, there's datums, and there's datum simulators. Now I'm talking about the 2009 standard. In the 94 standard, they still call out datums, they still call out datum features, but datum simulators in that, in that version of the standard is called the true geometric counterparts. So what I want to do is I want to clear up what datums really are. Datums are either points, axes, or planes. That's all they are. Okay, so you don't want to be pointing to, let's say, this part right here and say this is a datum. Because really, datums, like I said, are points, axes, or planes. That's all they are. And what are datums really? Well, the function of datums at the end of the day is to really create what they call a datum reference frame. Now, a datum reference frame is really this, okay? It's three perpendicular planes. Each of these planes are datums, or one form of datums like planes, axes, and points, but in this particular case, this is what we call the datum reference frame. Now, you've got three planes, three datum planes. The intersection of these three planes will create three axes. Then the intersection of these three axes will create a datum point right in the middle. So once again, let me explain this real quick. I know this is kind of going over most people's heads. These three planes are your datum planes. Intersection of these three planes are your datum axis. The intersection of all these axes will give you a datum point. Now this is, like I said, this is what you call a datum reference frame. This is also known as the Cartesian coordinate system. Okay, remember, you got to use the right-hand rule. The right-hand rule will give you x, y, and z components. Right? In addition, you have rotation, you have u, v, and w, and in all cases, you have 6 degrees of freedom that you guys need to control on the part in order to create an inspection. Now, what does the datum reference frame do? Well, it gives you an origin and a direction of your measurement. In other words, you know that the intersection of all these planes create a datum point. That is the origin of the datum reference frame, or your Cartesian coordinate system. Now these planes will tell you, hey, going this way is positive, going back is negative, and so forth. It'll give you a direction. And what that does at the end of the day is that for those of you guys that do CAD design, remember when you guys do CAD design, let's say you got this weird funky part, you always start out with an origin. Okay, there's always an origin, and basically with that origin, you guys will create a sketch and you guys will extrude a part. Okay. Now, there's a lot of misconception. Well, some may think that the origin is the datum reference frame, and it can be if it's designed correctly. I'm going to get into in a later video. But really, what I'm saying is that, look, if it's designed correctly, the origin and let's say your CAD model can be the datum reference frame. And why is that so important? Well, because what you want to do is basically throughout the life cycle of this design, you got it all modeled up in CAD, whether you guys use CATIA, NX, SolidWorks, or whatever it is. Okay, you guys will take that CAD model and give it to the guy that's going to program it, so you guys can get it made. That will be, that will get converted into a CAM software, and the CAM software will create all the tooling codes, all the G codes used to cut whatever this part is. Okay, now once you have the physical part, then that part will get transferred to the inspection guy, and that inspection guy will reuse the same CAD software, and the name of the game is to recreate this datum reference frame correctly, so that when they inspect the part to the CAD model, that it is inspected to the right and correct origin. The problem is that if you don't recreate this datum reference frame correctly, that, well, you know, if the part is this way, you're going to get some crazy numbers and you will never be able to validate the part. So going back to what I said, like I said, datums are either points, axes, or planes. The intersection of all the planes will give you datum axes, and the intersection of all the axes will give you a datum point. And remember, these are true 90 degrees apart. It's not 89 or 91. These are true 90 degrees apart. So the next time someone says, look, this is a datum, no, it's a datum feature. Okay, this is a feature. These are datums. They're either points, axes, or planes. So in a later video, I'm going to get into what datum simulators are, and how do datum features create datum points and planes, etc. I'll get into another later video, but really, at the end of the day, this is what datums are: points, axes, or planes. And what do? They create this datum reference frame, or what you know as the Cartesian coordinate system. So thank you for visiting my channel. Hit the like button, hit the subscribe, tell your friends about it, and we'll see you next time.